In our next video, we're going to consider how we find the vertex and plot 7 points for the equation of a parabola that looks like this. 3/5 x squared minus 2/5 x plus 1. Now, as we examine the coefficients of that parabola, we see that a is 3/5, b is negative 2/5, and c is 1. So we use our equation to find the x-coordinate of the parabola again, which is negative b over 2a. And if we put numbers into this, b was negative 2/5, and a is 3/5. So because we have a minus sign out in front of this, from this minus sign right here, and there's another minus sign here, we know that those will cancel. So our result is going to be positive, and it will be 2/5 over, and then in the denominator here, 2 times 3/5 is 6/5. And then this is the same as 2/5 times 5 over 6, because we recall that when we divide by fractions, we flip the bottom fraction, inverting it, and then change the division into multiplication. We can cross-cancel both ways, and we end up with the result 1/3. So at this point, that's the x-coordinate of our vertex, and now we need the y-coordinate. So we're going to find the y-coordinate by doing synthetic substitution again. We have 3/5, our coordinates are a, b, and c, 3/5, negative 2/5, and 1, our coefficients rather. Okay, so we bring down the first one, which is 3/5, and then we multiply 1/3 times 3/5, which will give us 3 over 15, or we can cross-cancel the 3's, and we get 1/5. And then we add these two, negative 2/5 plus 1/5 is negative 1/5. Multiply 1/3 by negative 1/5, and we get negative 1/15. Now 1 is the same thing as 15 over 15. So 15 over 15 minus 1 over 15 is 14 over 15. So that means that our vertex has the coordinates 1/3, comma, 14 over 15. And just one other word about this, which is the axis of symmetry. Now, this particular parabola opens up, so it's a vertically opening parabola, so consequently the axis of symmetry is going to be a vertical line, and in this case, it is the equation x equals 1/3. Okay, so that equation has exactly the same value as the x value of our vertex, and that's because the axis of symmetry passes through the vertex. So then in the next step, we're going to make a t-chart and be able to plot 7 points that will help us to draw a graph of this particular parabola. So we are going to make 4 columns, and our parabola was y equals 3/5 x squared minus 2/5 x plus 1. Okay, in our first column, we have the coordinates of the basic parabola, the x-coordinates of the basic parabola. And in our last column, we have the y-coordinates of the basic parabola. Now, we are going to modify these somewhat, and we'll do this in just a moment. Okay, so if you recall, the x-coordinate of our basic parabola was 0, and then the other x-coordinates we used were 3 to the left of the x-coordinate of the vertex and 3 to the right. of the x-coordinate of the vertex. Okay, and the coordinates of our vertex were 1/3 and 14/15. Okay, and we will discuss what happens with the y-coordinates in just a moment. Now, first of all, we notice that our x-coordinate is a fraction with a denominator of 3. So we're going to change all of these values for the x-coordinates of the basic parabola into fractions that have a denominator of 3. Okay, and so I'm just multiplying each one of these by 3 over 3. And so now to get the x-coordinates of this parabola, y equals 3/5 x squared minus 2/5 x plus 1, we're just going to add these values to the vertex value for the x-coordinate of the vertex. So 1/3 minus 3/3 is negative 2/3. 1/3 minus 6/3 is negative 5/3. And 1/3 minus 9/3 is negative 8/3. Now going the other way, we're going to add 1/3 plus 3/3 is 4/3. 1/3 plus 6/3 is 7/3. And 1/3 plus 9/3 is 10/3. Okay. So that's how we get the x-coordinates of those points that we want to plot. Now, to do the y-coordinates, we recall that the y-coordinate of the vertex was 0, and that the other y values were 1, 4, and 9. So in other words, negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. And we do the same the other way. Okay, now, here's a key point though. Right, we have to take notice of this coefficient in front of the x squared. Right, it's very important to remember that a is 3/5, because that's going to have an effect on the y-coordinates of this parabola. So what we're going to do is multiply each one of these by 3/5. And we do this to the y-coordinates of the basic parabola anytime the coefficient of the x squared term in our parabola equation is not equal to 1 or negative 1. Well, if it were negative 1, we would make all of these values negative. Okay, so this is what we're going to do in this case. So we have, now this turns out to be 3 over 5, which also happens to be equal to 9 over 15. And the reason why I'm writing it in terms of 15ths is to get a common denominator with the y-coordinate of the vertex. So the next one is 12 over 5, which is the same as 36 over 15. And then the last one is 27 over 5, which is 81 over 15. And so we're going to get those same values going this way: 9 over 15, 36 over 15, 81 over 15. So now we're going to add 14 over 15 to each of these values. So 14, and all we have to do, since the denominators are the same in each case, all we have to do is add the numerators. So 14 plus 9 is 23, so we get 23 over 15. 14 plus 36 is 50, so we get 50 over 15. And 14 plus 81 is 95, so we get 95 over 15. And then we get those same values down here. 23 over 15, 50 over 15, and then 95 over 15. So at this point, I would say my recommendation is to plot these points on Desmos. Right? This is a good activity. Plot these points on Desmos, plot the points first, and then enter this equation and see if the equation of this parabola, if the curve from the parabola passes through these points. So that's how you make a t-chart for graphing a parabola.